Hello guys, welcome back to our channel. Today we are going to solve the most important question from module 1, that is show that gamma of 1 by 2 is equal to under root of pi. This is most repeated and most important question. Now we are going to solve the problem. We know that gamma of n is equal to 2 into integration of 0 to infinity e power minus x square into x power 2m minus 1 into dx. This is called equation 1, and same as gamma of n is equal to 2 into 0 to infinity e power minus y square into y power 2n minus 1 into dy. This is equation 2. We know that the two formulas of gamma of m and gamma of n. Here we have considered this is a x integration, this is a y integration. Now we have to multiply gamma of m and gamma of n. Gamma of m into gamma of n is equal to 2 into 0 to infinity will come e power minus x square into x power 2m minus 1 into 2 into integration of is equal to 0 to infinity e power minus y square into y power 2n minus 1 into dy. Here dx will come. Next we have to multiply the equation. Then for m is equal to 4 into 0 x is equal to 0 to infinity and integration y is equal to 0 to infinity e power minus x square plus y square into x power 2m minus 1 into y power 2n minus 1 into dx into dy. Let we consider m is equal to 1 by 2 and n is equal to 1 by 2. This is called equation 3. Now the m and n value add in the equation 3. It become m value 1 by 2 into 1 by 2 is equal to 4 into x is equal to 0 to infinity and y is equal to 0 to infinity. Here e power minus x square plus y square into x power 2 into m value is 1 by 2 minus 1 and y power 2 into 1 by 2 minus 1 dx into dy. Here 2 cancel, 2 get cancelled. Then here remaining is 1 minus 1 become 0 and 1 minus 1 become 0. Now the next step, it become multiply of gamma of 1 by 2 become gamma of 1 by 2 whole square. Then 4 into x is equal to 0 to infinity integration y is equal to 0 to infinity. Here e power x square plus y square, where x power becomes 0 and y power becomes 0, dx into dy, where anything power is 0, then the value is 1. Here the value is become 1 and 1 into anything is the value. Then it become gamma of 1 by 2 whole square is equal to 4 into x is equal to 0 to infinity and y is equal to 0 to infinity. It become e power x square plus y square into the one is, then it become same dx into dy. Now let we consider x is equal to r cos theta and y is equal to r sin theta. And we in the previous theorem we know that x square plus y square value is equal to r square and dx dy is equal to r dr d theta. Therefore now add the x and y value in the above equation 4. Now equation 4 becomes some gamma of 1 by 2 whole square is equal to 4 into it become r is equal to 0 to infinity and theta is equal to 0 to pi by 2 e power r square into r dr into d theta. In the next step we have integration with respect to d theta. Then it become gamma of 1 by 2 whole square is equal to 4 into r is equal to 0 to infinity into integration of theta. Then the integration of d theta become theta. Now e power minus r square into theta. Now the integration is 0 to pi by 2 into dr. Now the value, substitute the value inside the theta, then it become gamma of 1 by 2 whole square is equal to 4 into r is equal to 0 to infinity and e power minus r square into r, it become pi by 2 minus 0 into dr. Now the pi, it become pi by 2. Now the pi by 2 is constant value, then we will directly take the common into outside, then it become gamma of 1 by 2 whole square is equal to 4 pi by 2 to integration of r is equal to 0 to infinity e power r square into r dr. Let we consider r square is equal to t and 2r dr is equal to dt, where 2 will go this side, then it become divided, then r dr is equal to dt by 2. Then add this value into the above equation 5. Then it become gamma of 1 by 2 whole square is equal to 4 by 2 into 2 t is equal to 0 to infinity and e power minus t into r dr become dt by 2. Now here we know 2 1s are 2 2s are, it become gamma of 1 by 2 whole square is equal to 2 pi into integrate with respect to dt, then the integration with respect to dt, then it become e power t become e power t divided by minus 1, value is infinite 0 to infinity, then 2 is there, the 2 will come common, then the add the value into this, then gamma of 1 by 2 is equal to whole square, then 2 will cancel, then remaining is pi, then this value will become minus e power minus infinity minus e power 0, then the value is become 1 by 2 whole square is equal to pi into 0 plus 1, then gamma of 1 by 2 whole square is equal to pi into 1, then gamma of 1 by 2 whole square is equal to pi, the square will come this side, means it become root, then the gamma of 1 by 2 is equal to under root of pi. This is the final solution for the theorem.